Welcome to this lesson on rational numbers. Please be sure you have these notes in front of you so that we can begin our notes. The learning objective for today says that I can explain the concept of a rational number. So for this first set of key concepts, we were going to talk about classifying ourselves based on our own characteristics. So a lot of us have Facebook or Instagram and we all have profile pictures. So let's go ahead and sketch us a profile picture that represents us. Now I'm going to draw myself, and I don't want you to draw me because this is all about who you are. So please draw yourself. And draw a picture that makes you individual, an unique individual. So for example, here I am. And let's give myself some eyes. Let's give myself a nose, a mouth, some ears, and hair. Alright, so this is me. So the reason why this makes me unique is because I'm wearing a blue math shirt. So I'm a math teacher. My favorite color is blue. So that's my profile picture right there. Alright, so now that we've drawn ourselves, you drew yourself, you didn't draw me, let's go ahead and classify ourselves based off of these characteristics. Now your answer is going to be different from mine because we're two different people. So our first question says, are you human? Yes, I'm going to write that down. Second question, are you in the 6th grade? I am not, but your answer might be different. Are you a student at Ramona Middle School? I am not, but your answer will be different. Are you a boy? Yes, your answer may or may not be different. Are you a soccer player? No, your answers may be different than mine. So just like we can call ourselves different things, some people are good at sports, some people are good at video games. So there are many different things that you can refer to yourself. Like I can refer to myself as an adult, I can refer to myself as a teacher, and a human being, so I can call myself many different things. Just like we can call ourselves different things, numbers can also call themselves different things as well. Our first vocabulary word is called whole numbers. And whole numbers are counting numbers from 0 to infinity. So for example, 0, 1, 2, 3, 4, and so on are examples of whole numbers. Our second vocabulary word is integer, and an integer is a positive number, a negative number, or 0. Here are some examples of integers. We have negative numbers, and we have positive numbers. Take note that integers are not fractions, and integers are not decimals. Our next vocabulary word is decimals. And there are two types of decimals that we're going to discuss. The first type of decimal is called a repeating decimal, and these are decimals which have a repeating digit or a repeating pattern of digits. So for example, that could be an example of a repeating decimal because the digit 3 keeps repeating. They would usually write it like this with a bar notation right above it, indicating that the 3 repeats. The next kind of decimals is called a terminating decimal, and a terminating decimal comes to an end and it does not go on forever. So 6/10 would be an example of a terminating decimal because it stops at the 6, and 25/100 would be an example of a terminating decimal because it stops at the 5. Fractions, which is the next vocabulary word, means part of a whole. So 7/9 is an example of a fraction because 7/9 is part of a whole. 13 1/2 is also an example of a fraction because the 1/2 is part of a whole. Our last vocabulary word is called rational numbers, and any rational number can be written as fractions. So for example, if I take a number a, which could be any number in the world, I can write it with a denominator of b. So a over b becomes a fraction. But b cannot equal 0. You can never have 0 on the denominator. So any rational number can be written as a fraction. So now let's go ahead and start the key concepts. We're going to use this graphic organizer to discuss the vocabulary words that we mentioned on the left-hand side. So if you could, let's go ahead and use some color pencils and color the inner circle yellow. The next inner circle would be red, and the outer circle would be blue. The most inner circle, which is the yellow circle, is known as the whole numbers. And whole numbers could be 0, 1, 2, 3, and so on. So any counting number is considered a whole number. So like 50, eventually we can count to it. 1,000, eventually we can count to it. So it's any positive whole number. In the red circle, we have the integers. And an integer is considered as any whole number that is inside of the yellow circle, and it could also be any negative number. So we can have -3, we can have -2, we can have -1, we can also have -50, and we can also have -1,000. So an integer includes any negative number and any whole number, and including 0. Now the blue circle consists of our rational numbers. Notice that within the blue circle we have the whole numbers, which is the yellow circle. We also have integers, which is inside the red circle. So rational numbers is everything inside of the blue, the yellow, and the red. So some things that could be considered rational numbers are fractions, like 1/2. Or you can also have a mixed number, which is 4 3/4. Those are considered rational numbers because you can write them as fractions. Now we can also have terminating decimals, such as 75 hundredths, and you can also have repeating decimals, which is also a rational number. So once again, a rational number is anything inside of the blue, red, and yellow circle. So let's use these key concepts to go ahead and classify the following examples. So example 1 is asking us to classify 75. We know that 75 is a whole number, so we can call 75 a whole number. It's also a positive number, so we can classify that as a whole number. We know that 75 is also an integer because it's a positive whole number, and all positive whole numbers are known as integers. We can also classify 75 as a rational number because we can write 75 as a fraction by placing a 1 under it. So we know that we can call 75 3 different names. We can call it a whole number because it fits the classifications of the yellow circle. We can call it a integer because it fits the classifications of the red circle. And we can call it a rational number because it fits the classifications of the blue circles from the key concepts. So example 3 is asking us to classify -3. We know that -3 is a negative number, so it cannot be a whole number. So it doesn't fit into the classification of the yellow circle from the key concepts. We know that -3 is a negative number, so it does fit into the classification of the red circle from the key concepts. So we can call -3 an integer. We can also call -3 a rational number because you can write -3 as a fraction by placing a 1 below it. So we can call -3 an integer, and we can call -3 a rational number. So example 3 is asking us to classify the following. 3/4 is the fraction they're giving us. And we know that 3/4 cannot be a whole number because it doesn't belong in the yellow circle from the key concepts. We know that 3/4 is not an integer because it doesn't fit into the category of the red circle in our key concepts. But we know that 3/4 can be a rational number because it is written as a fraction. So 3/4, we can only call it a rational number. So example 4 is asking us to classify -35 hundredths into different categories. We know that -35 hundredths is not a whole number because it doesn't fit the classifications of the yellow circle from the key concepts. We also know that -35 hundredths can't be a integer because it doesn't fit the classifications of the red circle. But we know that -35 hundredths can be a rational number because this rational number can be written as a fraction. So we can write -35 as our numerator and place it over 100 because it's in the hundredths place. And then we can reduce by dividing the top and bottom by 5. So our negative is going to stay the same. Our top numerator is becoming 7, and the bottom number becomes 20. So we just wrote negative 35 hundredths as a fraction. So we can only call it a rational number. So pause the video, complete these guided problems, and then play it back for some feedback. So for example 5, they're giving us a word problem that talks more about rational numbers. Problem 5 says, there are 2 bags of candy and 5 friends want to split it evenly. Each person will get blank of the bag of candy. So the way that we can write this is 2 bags of candy will be divided by 5 friends. Another way to look at this division problem is to look at it as a fraction. You can write 2 divided by 5 as 2/5. So for our problem, we can write that each person will get 2/5 of the bag of candy. So pause the video, complete these guided problems, and then play it back for some feedback. So now that you've completed the lesson, go ahead and self-assess yourself. If there's any part of this video that you did not understand, please go back and watch it again. Also, come to class with some questions so that we can discuss anything that you are confused about.